Okay, so good day class. Let's continue with our lesson. So for today, let's have now the sewage disposal system. Okay, so you have this, the private sewage disposal system. So for disposal phase, this is the final stage of the plumbing process where used water and water carried waste are brought to various disposal outlets. No, like for example, you have your house drain or building drain. So that's maybe for that connection, you can connect that for the public drainage, and then from the public drainage you have there the disposal phase. Okay, so for definitions, let's have first the septic tank. It is a watertight covered receptacle designed and constructed to receive the discharge of sewage from the building sewer, separate solids from the liquid, digest organic matter, and store digested solids through the period of detention, and allow the clarified liquids to discharge for the final disposal. So from the septic tank, after that, you have the outlet that is going to the public drainage. Okay. So sludge is a solid organic matter that are denser than water and settle down at the bottom of the septic tank. So that is the excreta. No? You have the solid particle of the solid particle coming from the water closet. And then you have the scum, that is lighter organic material that rise to the surface of the water. And then effluent, you have the liquid content of the sewage. So there are also bacteria in the septic tank, so to encourage the decomposition. So if ever you have the connection from your shower, and then you connect also your I think the water closet. So from shower and water closet, it goes to your septic tank. If that's the case, maybe your septic tank will be full, or maybe your septic tank maybe at, I think, maybe 2 to 3 years it will be full, no, since you have that soap in your shower compartment or shower receptor that can kill the bacteria in the septic tank, so that the decomposition of the decomposition of the waste there can be blocked, or since the bacteria already died because of the soap in your shower compartment or in your shower drain, no, that goes to the septic tank. So by the way, for the bacteria in the septic tank, you have the aerobic bacteria that is relies on oxygen to survive, and then also an anaerobic bacteria can survive in places without oxygen. Normally, the many bacteria in the septic tank composes of anaerobic bacteria. Okay. So this is the sample drawing of a septic tank. So the minimum dimension of septic tank is, for the length, that is 1.5 meters or 1,500 millimeters. And then the width is 900 millimeters or 0.9 meters. And then the depth, you have 1.2 or 1,200 millimeter. But now in the National Plumbing Code provision for septic tank, it should be of 3 chamber. So prohibited na for usage ang 2 chambers. But in some cases, there are also exemption. If you have a smaller building and a smaller area, you can just use 2 chamber septic tank. Okay. So single chamber septic tank, you have this drawing. So it should have a manhole in every chamber, so that when you are to clean or maybe to pump the sludge here in the septic tank, you can open the manhole. Okay. So this is also a septic tank with one chamber or single chamber. You have the manhole here and an outlet. So all septic tank should have an outlet, so that the water, no, you have water coming from, or wastewater coming from your toilet and bathroom, lavatory, floor drain, and shower compartment or shower receptor, can pass through the septic tank and goes out, no, to public streets, sewer, or to drainage, public drainage. Okay, so for the design criteria for the sewage disposal, you have, for plans, should show all dimensions and reinforcing structural calculation and such other pertinent data as needed. So in commercial building, you are to require structural, or at least a calculation of pipes to be used in your drainage system and sewage system. Next, we have the quality of design. So such shall be such as to provide a clarified effluent of acceptable standard, and shall provide adequate space for sludge and scum accumulation. So for this quality of design, it should have the number of occupants, or maybe a number of toilet and bathroom in the building. And then the materials, so constructed of durable materials, not subject to excessive corrosion or decay, and shall be watertight. So materials, most common is cement, or maybe a concrete, or a prefabricated cast iron. Okay, so for the compartment, have a minimum of 2 compartments, but for the requirements today, you should have at least 3 chamber or compartment. So first compartment, not less than 2/3 capacity of the total capacity of the tank, not less than 2 cubic meter liquid capacity, and shall be at least 0.9 meters in width and 1.5 meters long. Liquid depth is not less than 0.6 meter nor more than 1.8. So normally when we have our septic tank construction, the dimension is 4.4 for the length, and then the width is 1.5, and then the depth also 1.5. Okay. So for the secondary compartment, a maximum capacity of 1/3 of the total capacity of the tank, and a minimum of 1 cubic meter liquid capacity. So you have a volume of 1 by 1 by 1. No? That is for the second compartment. So in septic tank having over 6 cubic meter capacity, the secondary compartment should not be less than 1.5 meter in height. So therefore, you have 1.5 cubic meter volume of liquid capacity for the secondary compartment. And then the manhole. And then this one, you have to maintain a slope of 1:10 at the bottom of the digestion chamber to collect the sludge and make it easily accessible by the manhole. So for this one, it should have a 1:10, but in our design now, we have 1:5 slope for the digestive chamber. Okay, so to collect the sludge and accessible by manhole. So this is 1:5. Okay, and then as of this discussion, this is one. As to this discussion, this is 1:10. But you can use 1:10. Okay. So next is the manhole. So with at least 2 manholes, or that is 508 millimeter in minimum dimension, or that is 0.5 meter in minimum dimension, one over inlet, other over outlet. So wherever first compartment exceeds 3.7 meters in length, an additional manhole required over the baffle wall. Okay. So if ever you have a digestive chamber of at least 2 meters in length, so you just have at least one manhole for that digestive chamber. But for every chamber, you should have at least one manhole with a dimension minimum of 0.5 meters, so that a person can enter that manhole. Okay, so that dimension of 0.5, so maybe one person can enter that hole. Okay, so next is the sizes of pipes, inlet and outlets under vertical legs. So inlet and outlet pipes, diameter size not less than the sewer pipe. But in the construction, we will just use the 4 inches diameter for inlet and outlet pipes, since the standard dimension for the waistline used in construction is 4 inches in diameter. And then vertical legs of inlet and outlets, diameter size not less than the sewer pipes, nor less than 104.6 millimeter, or that is 4 inches. So normally we will use 4 inches in diameter. Then length and location of inlet and outlet shall extend 101.6 millimeter above and at least 304.8 millimeter below the surface of water. Okay, so based from this drawing, this is the inlet that is 100 millimeter below, and you have the 300. It depends on the depth. So normally you have 4 inches for the I think this is the air level. No, you have the I think that is air compartment for this, since you need also an air so that the flow of liquid here in septic tank can directly flow into pipes. Okay, so you have 4 inches, so based on design. Okay, location of inlet and outlet. So for inlet, that is 4 inches. For outlet, that is 304. This one. So 4 inches, and then outlet is 304. Okay. So maybe I will discuss also this design when we'll have our design for the waste and sanitary line. And then invert of the inlet pipe shall be at a level not less than 50.8 millimeter above the invert of the outlet pipe. Okay, so for the inlet, this one, so the invert of the inlet pipe is 50 millimeter above the inlet invert of the outlet pipe. So you have, since this is 4 inches, so half of that is 50. So invert meaning that is the lowest point of the diameter of the pipe, invert. Okay, so that is the lowest point of the diameter of the pipe, that is the invert for the inlet. And then for the outlet, so the invert here is this one, so maybe that is 50 millimeter distance from the inlet invert to the outlet invert. Okay, and then next is the vent diameter, so equal to the cross-sectional area of the house sewer. So normally we will use 4 inches. So next is the airspace. So by the way, that is the airspace. So side walls shall extend 228.6 millimeter above the liquid depth. So by the way, this is the airspace. Okay, this one. So the 4 inches distance from the inlet to provide you with an airspace, okay? So that the flow of liquid continuously flow through the pipes. Okay, and cover of septic tank shall be at least 50.8 millimeter above the vac vent opening. And then next we have the partition between compartments. An inverted fittings equivalent in size to the tank inlet, but in no case less than 104.6 millimeter in diameter, or that is 4 inches, shall be installed in the inlet compartment side of the baffle with the bottom of the fitting placed midway in the depth of the liquid. Wooden baffle are prohibited. So you have, so as I discussed, you have the invert of the inlet, so lowered for the partition. The next pipe there is lowered 50 millimeter of the outlet invert. Okay. So next is the structure. So shall be capable of supporting an earth load of not less than 14.4 kilopascal. No? 14.4 kilopascal. So for the load, so maybe when you design the slab for the cover or cover of the septic tank, you will have the load of not less than 14, or maybe when I design a septic tank cover or septic tank slab, I will use 15 kilopascal of load. Okay. So next is the capacity. The capacity of septic tank is determined by the number of bedrooms or apartment units in dwelling occupancies, by the estimated waste and or waste sewage design flow rate for various building occupancy, or by the number of fixture units of all plumbing fixture, whichever is greater. So you already know what is fixture unit. Okay. So it depends on, as what I have said, it depends on the occupants and the number of toilet and bathroom for the capacity of the septic tank, and maybe the dimension of the septic tank. So the capacity of any one septic tank and its drainage system shall also be limited by the soil structure classification in its drainage field. So it depends. If ever you have an apartment building, maybe you can use 6 inches diameter for the soil stock pipes. So maybe in the septic tank also, the inlet, you will use 6 inches in diameter. Okay. Next, for the location, should not be located underneath the house. So it should be located outside the building. And maybe you can have this at your garage, or maybe at your carport. So you can have your septic tank there, but it should not be located inside the building or underneath your building. Then at least 15 meters from the water distribution system. So in the certification from the master plumber, it should be that the septic tank is 25 millimeter in distance from your deep well. Okay, so there should no deep well within a 25-meter radius from the septic tank. Okay. So you have 3 degrees or grades of wastewater. First is the gray water or the area water. So wastewater with an exception of human waste. This is from laundries, wash basin, that is from lavatories, sink, tubs, and etc. Next is the black water. This is the water plus a solid and liquid human waste. So for black water, this is coming from the water closet. And then you have the storm water. This is from the rainwater only. Okay. Let's have the classification of sewers. First is the combination public sewers. You have the oldest variety. This carries both storm and sanitary waste. And then storm sewers, you have also you have the sanitary sewers. So these are the classification of sewers. For sanitary sewers, this carries regular sanitary waste only. I think I already discussed this in storm water system. Stormwater system, you have also the combination stormwater, and then the storm or the individual, and then the natural. But for the sewer, you have the combination public sewer, storm sewers, and the sanitary sewers. Also, for sanitary sewers, this terminates in a modern sewage disposal treatment plant. Okay. And built at a depth of 3 meters for tributaries. So there are two types of sanitary sewers. You have the tributary sewer, the termination point of individual unit or structure, usually round shape with diameter between 0.6 to 1.2 meters, and then made of vitrified clay or cement pipe, often installed by the curb line before the street. So you have the think you have the sidewalk. No? Normally, you have the sidewalk. Under the sidewalk is the tributary sewers. Okay. They normally laid in the northern or eastern side of the streets with east-west or north-south orientation. Next is the intercepting sewers, also called as collecting sewers. Termination point of tributary sewers, and then placed much lower of the ground from 4 to 30 meters in depth. Then you have to, and varies in shape, but have a diameter or effective opening ranging from 0.6 meters to 3 meters. So you have the varying shape of the intercepting sewer. You have circular, ovoid, and oval. So for the slope of the sewer, no, or maybe a drainage, you can have a slope of 1:50, or that is 2% slope. So normally when we have the construction of drainage system or maybe a canal on the side of the streets, at least you will have a slope. No? You will have a slope of 2%. Do not just follow the slope of the road. Okay. And then lifting station are placed at certain intervals, and pumps or sewage ejectors are used to lift the waste. Sewer terminates at the disposal plants. Then for the requirement, sewers required. Drainage pipe of all buildings shall be connected to the public sewer. When not available, they shall be connected to an approved private sewage disposal system. And then public sewer may be considered as not being available if it is more than 61 meters from any proposed building or exterior drainage facility. And for the exemption, single family dwelling with an existing private disposal system. So this is the septic tank, no? Private sewage disposal system. Example of that is the septic tank. So may not be connected to a new public sewer when no hazard, nuisance, or unsanitary condition is evident, and when there is no sufficient grade or fall existing to permit proper drainage flow by gravity to the public sewer. So normally for the sewers class, maybe you in other countries they use this sewage treatment plant, so they don't have their septic tank. They just connect their pipes to the public sewer or maybe a private sewage disposal system. Okay. So damage to public sewer or private sewage disposal system. So it is unlawful to discharge any ashes, cinders, solid, drugs, flammable, poisonous, explosive, liquids, or gases, oils, grease, and other thing whatsoever which would cause damage to the public sewer or public disposal system. No rain, surface, or subsurface water shall discharge into any excreta drainage system. So do not connect your stormwater system or stormwater line to your septic tank. Okay. And then no cesspool and septic tank effluent, seepage, pit, or under drain system shall be connected to the excreta building sewer leading to the public sewer main. And no commercial food waste grinder shall be connected to a public or private sewage disposal system. So for food waste grinder, you can have a grease trap. So next to your food waste grease trap, and then you have the catch basin going to a cesspool or a seepage pit. Okay. So the size of sewer, the minimum size of any building sewer shall be determined on the basis of total number of fixture unit drained by such sewer. No building sewer shall be smaller than 150 millimeter diameter, nor less than the size of the building drain. So normally, if you have just the commercial building, two-story commercial building, or at least three-story, and also for the residential building, you just use, or you can use 4 inches in diameter, or that is 104.6 millimeter diameter. Okay. So for the installation of sewer, so building sewer shall be run in practical alignment at a uniform slope of not less than 2%, or that is 21 millimeter per meter towards the point of disposal. So you just follow this slope so that the excreta drainage shall directly flow through pipes. Okay. Exception when impractical due to depth of street sewer, structural features, or to adverse arrangement of building to obtain the slope of 2%, sewers 102 millimeters and 152 millimeters in diameter may have a slope of not less than 1%. So maybe when we will have our sanitary and waste line distribution system, maybe I can elaborate this installation of sewers discussion. So maybe I will have an example of a drawing or a design for this installation. Okay. Next is no building sewer shall be installed less than 0.6 meter from the outer face of any building foundation, nor less than 0.3 meters below the finished surface of the ground. So I already discussed this in sanitary drainage system, the previous topics. So this one. So this is your building and this is your building drain. So for the building sewer, the distance is 0.6 meter, and then the depth for the building sewer is 300 or 0.3 meters. So location of building sewer is relation to the other services shown below. 0.6 meters from any building or structure, 15.2 meters from water supply, and then 15.2 also from streams, 0.3 from domestic supply pipes, and 0.3 from the public water main. So building sewer or drainage pipe of clay or materials which are not approved for use within a building shall not be laid in the same trench as water pipe unless the bottom of the water pipe is 0.3 meters above the top of the sewer. This is from the National Plumbing Code 1208.1.1. So this one, from the water line that is below, or you have this as your water line, 300 millimeter below, or that is 0.3 meter below is your building sewer. Or maybe you can have also the building drain, okay, that is 0.3 meters in distance. So the water pipe is placed on a solid shelf excavated at one side of the common trench with a minimum horizontal distance of at least 0.3 meters from the sewer or drain pipe. So this is from the National Plumbing Code 1208.1.2. Okay, this one. So this is the water line. So you have 0.3 meters horizontal and vertical distance from water line to your building sewer is 0.3 meter. So that's the minimum distance. So water pipes crossing sewer or drainage pipe of clay or materials which are not approved for use within a building shall be laid a minimum of 0.3 meter clear above 0.3 meter clear above the sewer or drain pipe. So water pipe joint shall be installed not less than 3 meters away from the sewer line in both direction. This one. So your building sewer that is 0.3 meters below the water line. So the distance from your building sewer to your pipe connection, or maybe you have this coupling, no? So that is 3 meters minimum distance. Okay. So next is disposal fields. Private sewage disposal system common in rural areas for structures with large adjacent open fields. This one. So you have disposal fields. So it depends on your area, but here in cities, we will provide every building with a septic tank. But in open fields, you can have your disposal fields, maybe the areas 50 meters from your house or building. Then you have the area dependent on the required septic tank capacity or estimated sewage flow rate, whichever is greater, and the type of soil found in the excavation. Next is the distance from water table. Okay, so no excavation for leach bed shall extend within 1.5 meter of the water table. And then if you have a seepage pit, filter material in the trench shall terminate 1.5 meter from pit excavation, and the pit extended from such point to the seepage pit shall be of water type. So next is the seepage pit. This is a loosely lined excavation in the ground which receives the discharge of the septic tank, designed to permit effluent to seep through the pit bottoms and sides. So for seepage pit, it is just an excavated area. No? So for the capacity, based on the quantity of liquid waste and on the character and porosity of the surrounding soil. So for the size of the seepage pit, circular in shape, maybe you can also have rectangular or square, but it should be not less than 2.2 meters in the dimension or in diameter. Okay. So next, for the strength, you can have brick lining shall have a minimum compressive strength of 17,225 kilopascal. For the multiple seepage pit, it serves through a distribution box or shall be connected in series by means of watertight connection. The outlet shall have a vented leg fitting extending 304.8 millimeter below the inlet of fittings. Okay, so this one. So this is the inlet of fitting. This is your septic tank. This is the seepage pit. So you have the inlet, or this is the outlet now of the seepage pit. So you have that distance 0.3 meters, no, from the outlet, or maybe this is the outlet of the septic tank to the outlet of your seepage pit. Okay. So next is cesspool. This is a non-watertight line excavation in the ground which receives the discharge of a sanitary drainage system designed to retain the organic matter but permitted the liquid to seep through the pit bottom and side. So maybe it's just the same with the seepage pit, but for cesspool, you have there a cover. Okay. So this is an example of a cesspool. So it permits water to seep through bottom and the sides. So next is the temporary permits. So temporary permits expedient pending the construction of a public sewer. So long as it is established that a public sewer will be available in less than 2 years and the soil and groundwater condition are favorable. Also, as an overflow facility when installed in conjunction with an existing cesspool as a means of sewage disposal for limited minor or temporary uses. So next we have the private. Outside private is the oldest form of disposal of organic waste. Consists of a vault constructed of concrete or maybe just a seepage for the collection of raw sewage and wooden shelter. So this is now this is a private, and then this is the private vault. Okay. So commercial industrial liquid waste disposal. So for the requirements, when liquid waste containing excessive amount of grease, garbage, flammable waste, sand, and other ingredients, which may affect the operation of a private disposal system, an interceptor such as waste shall be installed. So for the disposal, waste from interceptor may be discharged to a septic tank or other primary system or into a separate disposal system. Okay, so you have next is the general guidelines for private sewage disposal system. Okay, so for the general guidelines, so you have this location of sewage disposal system. So for the first row, you have the minimum horizontal distance in clear required from. You have this maybe a building. Then you have this building sewer column, and then the septic tank, disposal fields, and the seepage pit or cesspool. So for buildings or structures, you have the distance from building sewer is 0.6, from the septic tank 1.5, disposal fields is 2.4, and from seepage pit or cesspool that is 2.4. So normally we'll have the buildings, the water supply or supply wells. You can have 15.2 for the sewer, building sewer. For the septic tank, distance from that water supply, you have 15.2. For disposal fields, you have 30.5. And then for seepage pit and cesspool, that is 45.7. Okay. And also you have there from cesspool to building sewer, so maybe none. So from septic tank, that is 1.5. So you just go through with these locations for the sewage disposal system. So you can download the PDF file for these slides. Okay. So next we have the sewage treatment plant, so STP. So some features of the sewage treatment plant, you have an aerobic system within the tank. You have also a submersible mixer to mix the waste and the water, and then a sludge waste pump that aids in clarifying, a decanter, and maybe a blower, and then a full electronic control system, etc. Maybe you have this sewage treatment plant and water treatment plant in your environmental engineering. So for this topic, maybe it will be elaborated to that subject. No? So you have this diagram or a sample diagram for the sewage treatment plant. Okay. So here in my slides or in my notes, you have the two most common type of sewage treatment. You have the activated sludge and the trickling filter process. Okay. So for the activated sludge process, so it involves a series of stations where a raw sewage must pass through. And then in the first phase, it gets rid of the heavy materials with the use of 3 different filter house. For the second phase, it clarifies the effluent. And then for the third phase, it hardens the sludge and convert it to fertilizers. So it produces water with 99.5% purity. Okay. So this is the activated sludge process. So first is the raw sewage inlet. Okay. And then it goes to a coarse grain house. And then you can go to a grit chamber, and some goes to the incinerator. And then from the grit chamber, go back to incinerator, and then other goes to the fine screen house. Okay, and then from the fine screen house, you can go through incinerator if ever that is not fine, no? So goes to the incinerator, goes back to by the way, for the incinerator, maybe this is the sludge here is being heated to become fertilizers. Okay, so from the fine screen house, you have the activated sludge tank, and then goes to the aerating basins, and then supplied by the powerhouse. You have the from the powerhouse, so it supplies the activated sludge tank and the aerating basin. And then from the aerating basin, you have the clarifier, and then you have the outlet for some coming from the clarifier, maybe the waste, and then goes from the clarifier goes to the chemical house, and then supplied by the vacuum powerhouse, the liquid extractor house, and then the dryer house, and then the warehouse. So maybe after the warehouse, that is now the 99.5% purified water, or maybe water produces 99.5% purity for this process. So another process is the trickling filter process. So also called as percolating or sprinkling filter system. This requires less mechanical elements and less stages. Produces water with 95% purity. So requires a large ground area for its building. So since you have a large area, maybe the collecting area for this trickling filter process, maybe it composes of a subdivision, or maybe too many houses, no? So this is the sewage coming from the building or from the houses, and then it have a rotating arm, and the sewage distributed evenly by sprayer. Okay, so maybe we can or you already discussed this in your environmental engineering. Okay, thank you. So that's all for the sewage disposal systems. So see you in our next video discussion. Thank you.